there everyone! Welcome to this week's Roundup, the home of the latest and greatest in data science. This week we're talking about DeepMind's new AI system Gato, how machine learning might make plastic infinitely recyclable, and how data is improving Formula One for teams and viewers. As always, don't forget to let us know what your favorite story of the week is, and like and subscribe to stay in the loop. For our first story this week, we're taking a look at DeepMind's new AI system Gato. Arguably, the objective behind a lot of AI research we see today is to create a system with artificial general intelligence, which is a system that can perform any task and can self-improve. While some people are skeptical about the possibility of reaching AGI, this week DeepMind took a small step in that direction by showcasing Gato, an AI system that can perform an incredibly wide range of tasks, ranging from generating images or playing video games to moving a robot arm in real time. While this isn't the first multimodal system researchers have created, the diversity of tasks that can be performed is truly a step forward. Similar to GPT-3, the Gato model also uses the transformer architecture. However, unlike GPT-3, which focuses only on language-based tasks, Gato also performs tasks that are traditionally reserved for reinforcement learning models, such as playing video games or navigating environments. Not only is the generalist nature of the system incredible, but its relative size is also worth mentioning. In terms of parameter count, Gato is orders of magnitude smaller than single-task systems like GPT-3. Parameters are the parts of the system learned from training data, and essentially define the skill of the system on a problem, such as generating text. Gato has just 1.2 billion parameters, while GPT-3 has over 170 billion. While Gato is currently best described as a jack of all trades and a master of none, the research team believes that with more data, parameters, and computing power, the system could be trained to perform better at an even larger number of tasks. Currently, the system performs better than an expert over half of the time on 450 of the 604 tasks in its repertoire. For those of you who'd like to know more about Gato, you can check out the link in the description below. And do let us know in the comments what tasks you'd like to see performed by an AI. Our next story takes a look at how a group of scientists at the University of Texas have created a modified enzyme that can break down plastics in days that would otherwise take centuries to degrade. The scientists landed on its exact structure using machine learning. An algorithm was fed with 19,000 protein structures and taught to predict the positions of amino acids in proteins that aren't optimized for their local environments. The enzyme they discovered breaks plastic down into its original chemical building blocks through a process called depolymerization. This then enables scientists to make fresh plastic from scratch without compromising on the structural integrity of the material, and without using additional petroleum resources. This is far more sustainable than traditional belt recycling, which melts plastic down and then reshapes it. The fact that the enzyme enables recyclers to make fully fresh plastic at each round of recycling means that plastic can be infinitely recycled without losing quality each time it's processed. While enzyme research into breaking down plastics is nothing new, most naturally occurring enzymes aren't able to break down a sufficiently large number of plastics in any pH or temperature conditions. This new enzyme, however, which the scientists have named fast PETase, can break down 51 types of PET across a range of temperature and pH conditions. In our next story, machine learning is driving improvements in Formula One. The sport is incredibly data-rich, and teams like Ferrari are leveraging this data to decide when to perform pit stops and how to precisely fine-tune cars at each stage of a race. At any given time, there are over 300 sensors on each F1 race car, generating more than 1.1 million data points per second transmitted from the cars to the pit. Not only is this information being used to help racing teams make better, more precise decisions, it's also being used to provide fans with interesting insights on broadcasts. A good example of this is the new undercut threat graphic, which can be used to show how close cars are to being able to overtake one another if they make a pit stop. Data is also being used behind the scenes to inform the engineering that goes into making Formula One cars. Cloud computing has been able to run aerodynamic simulations 70% faster than they have traditionally been performed. These simulations have been used to build a car that reduces downforce loss from 50% to 15%. This dramatic reduction offers the chasing driver a higher chance of overtaking, and in doing so offers more wheel-to-wheel action for the fans. This next generation car will be introduced in the 2022 season. Our final story this week takes a look at how Google is changing the way it reads skin tone information to be more inclusive and representative. For decades, tech companies have relied on something called the Fitzpatrick scale to analyze skin tones in their computer vision algorithms. The scale was originally developed in the 1970s and only contains 6 skin tones, making it not only outdated but also not inclusive. This is one of the reasons big tech and AI have historically been bad at identifying people of color. Google announced at the 2022 I/O Developer Conference that going forward they'll be using the Monk skin tone scale, a scale of 10 skin tones, as a standard across their products, in an effort to reduce bias in the datasets used to train AI, in everything from healthcare to content moderation. Google Images will also offer an option to sort makeup-related search results using the scale, and filters for people with more melanin are coming to Google Photos later this month. Further study is still needed to validate results that indicate a Monk over Fitzpatrick preference or whether a Monk approach leads to more equitable algorithms. But early results, especially for groups poorly represented in computer vision datasets, are promising. We can't wait to see AI and computer vision become more inclusive, and are incredibly excited about the push for representation from Google. That brings us to the end of another Roundup. Thanks for joining us. Don't forget to like and subscribe, and we'll see you at the same time, same place, next week.